Today we're going to be looking at Unit 10, Section 1, which is all about transformations. We're going to be looking at specifically translations, reflections, and rotations. A translation is when the object is moved around the axis, the x and y axis. The position of the object is changed. So look, all I'm doing is changing the actual position. There's no rotations, no reflections, no odd changing its orientation. It is just moving. Now, translation done on the graph is done by changing its x and y position. One way we see it is represented like this, where it specifically mentions how much x has changed, how much y has changed. So here's my original points for my triangle. So I'm going to apply this translation. 1 minus 5. 1 plus 2. 1 minus 5. 4 plus 2. 4 minus 5. 1 plus 2. Alright, so now I graph it. Negative 4, 3. Negative 4, 6. Negative 1, 3. There's a translation. Another translation we do is performed by a vector. A vector is where it's moving along an x and y coordinate. So this is moving over 3 down 2. So all my points are moving over 3 down 2. Over 3 down 2. And I can see those points created doing the same thing. 2 plus 3. 4 minus 2. Look. 5, 2. Negative 2 plus 3. 0 minus 2. 1 minus 2. 3 plus 3. 2 minus 2. 6, 0. So I said, here is our new triangle. Let's move along the vector. A reflection. The idea is a reflection is the reverse of an image across a line. Now typically we do reflections across things like the x-axis, the y-axis, and the line y equals x. But we do it along other lines as well. So this reflected across this line looks something like this. There's their triangle reflected across the blue line. So we have all these different lines we can reflect across. The x equals 0 line is actually the y equals the y-axis. Reflected. The y equals 0 line is the x-axis. Reflected. And then we have the x equals y line reflected. Now, here's what happens to all of these. When you're reflecting across the y-axis, the x-coordinate changes its sign. Sign's changed. When you're reflecting across the x-axis, the y-coordinate changes. And when you reflect across the line x equals y, you flip the x and y coordinates around. So these get flipped. So 5, negative 3. Let's look at examples of these. So, the reflection across the x-axis. What did I say I did? Well, first off, x-axis. The x-axis is right here. You think x, you think, oh, x coordinates change. No, you want to think the y coordinates change. The y coordinates flip signs. The y coordinates flip signs. So notice all my y's, their signs changed. Negative 2, negative 1. Negative 1, negative 3, negative 6, negative 1. Now another thing you can think about is look at the distance between the point and the line that's being reflected across. Distance of 1. Well look, distance of 1. Distance of 1, distance of 1. distance of 3, distance of 3. We'll come back to that again. Reflection across the y-axis. That's the y-axis. We change the signs of the x-coordinate. Notice how all my x-coordinates signs changed. So let's graph it. 2, 1, 1, 3, 6, 1. Now, same thing that I mentioned here about the distances. Look. Distance of 2, distance of 2, distance of 1, distance of 1. 6, 6. We'll come back to that. Now, this one's a challenging one. Reflection across the line y equals x, which is that blue line. Your coordinates flip-flop. So 1, negative 2. 3, negative 1. 1, negative 6. 1, negative 2. 3, negative 1. 1, negative 6. Now, I could do the same sort of thing in thinking about it, but it is a little bit more challenging. But distances, over 4, down 4. Over 3, down 3. Over 7, down 7. So it's a little bit different with the x and y coordinate. Now we're going to do a reflection across not one of those lines, but the line y equals 2. The line y equals 2 is right here. Notice it's reflecting the image across this line, and we got some points on the bottom, some on the top, and that's okay. I'm going to use that distance idea to make my life easy. Distance of 3, distance of 3. Distance of 5, distance of 5. Distance of 8, distance of 8. This goes off the graph. And there is my new reflected triangle. Rotation. The idea of rotation is the object is turned about a point. It's usually rotated 90, 180, or 270 degrees. So rotated 90. Clockwise. Back to its original. Rotated counterclockwise, 90 degrees. Now, back to its original, 180 degrees doesn't matter whether you go clockwise or counterclockwise. 180 degrees is the same regardless which direction you go in. So something to remember for here. Clockwise is that direction. Counterclockwise is rotated in that direction. So, now an easy way to remember how 90-degree rotations work, you flip your x and y coordinates. Now, just be aware, your negatives may or may not stay the same. Think about the quadrant that you're in and the quadrant you're going to. So what I'm going to do is I'm just going to flip these. 2, 3, negative 1, 4, 3, 1. I'm going to ignore the negative signs and just think about what quadrant I'm in. I'm rotating clockwise. So this point is being rotated into this quadrant. That's at negative x and negative y. So it's 4, 1. So it's become negative 1, negative 4. This one is being rotated into quadrant 4. Positive x, negative y. 3, 2, 2, 3. Same deal here. 1, 3, flip it, 3, 1. And there is my 90-degree clockwise rotation. Let's do the same thing, except we're going to do a 90-degree counterclockwise rotation. So again, I'm thinking about the quadrants I'm in. I'm rotating this direction. So same idea, I'm going to flip my x and y's. 1, 3, 3, 1. 3, 2, 2, 3. This guy's moving to quadrant 1. 4, 1, 1, 4. And there we go. 90-degree counterclockwise rotation. And last, 180-degree rotation. We change the signs of our x and y. And this makes our life easy. I don't really have to think about it. I just change the signs. And now I can graph it. -3, -2, -4, 1, -1, that should be a -3, -1, -3. That is a 180-degree rotation. Those are the transformations we're going to talk about today. See you next class.